Okay, in this lesson I am going to be talking about hypothesis testing. And we're going to be hypothesis testing for the proportion, which is the only type of hypothesis test we'll be doing on our course, on the Leaving Cert Ordinary Level course. So a few definitions just to start. First of all, something called the null hypothesis, and the null hypothesis is just a claim made about a population. If somebody makes a claim about a population, that is called a null hypothesis. For example, I might claim that most people believe in the existence of alien life. That's a claim I'm making about the population, and my claim can be true or false. I can claim anything really about the population. And the notation we use for the null hypothesis is this symbol here, H subscript 0. That 0 is a little subscript down there, sometimes called H0, but almost always called the null hypothesis. So the null hypothesis is a claim made about the population. It could be true or false. The alternative hypothesis is the mathematical opposite of the null hypothesis. So if I'm claiming that if the null hypothesis is my claim that most people believe in the existence of alien life, well, the alternative hypothesis would be that most people do not believe in the existence of alien life. And again, that can be true or false. But if the null hypothesis is true, then the alternative hypothesis has to be false. And similarly, if the null hypothesis is false, then the alternative hypothesis has to be true. They have to cover all possible bases. The notation for the alternative hypothesis is H subscript 1, H sub 1 or H1, but pretty much always we're just going to call it the alternative hypothesis. That's just the notation. We don't write out these big long words. We just have, like most of mathematics, a little quick way of writing it down. So for a claim like this, 8 out of 10 cats prefer Whiskas. There used to be an ad on the television. There used to be a brand of cat food called Whiskas. I don't own cats, so I don't know if it's still a thing. And that was their catchphrase, 8 out of 10 cats prefer Whiskas. Everyone of a certain age would remember that ad, or everyone, certainly in this neck of the woods, of a certain age would remember this kind of phrase, 8 out of 10 cats prefer Whiskas. And it's a claim made about the population of all the cats in the world, saying that 8 out of 10 of them prefer Whiskas, which was a brand of cat food. So this is a claim. So the null hypothesis in this case is the claim. It's 8 out of 10 cats prefer Whiskas. And I could write that out in words like that. I prefer to get, as soon as I can, to get this into mathematical language. And I think that's the best thing to do. So that's what I'm going to do. So I'm going to straight away kind of convert this English into a mathematical language. And I'm going to say, look, they're claiming that 8 out of every 10 cats prefer Whiskas. That means they're making a claim that the population proportion is equal to 8 out of 10. 8 over 10 is 0.8 or 80%. And I can write in the percentage or just the decimal. I can write 80%, or if I wrote 0.8, that would also be right. The null hypothesis is just the mathematical opposite of this. So it's the opposite of saying P is equal to 80%. Well, what's the opposite of saying P is equal to 80%? The opposite is saying that P is not equal to 80%. So one of those things is true. Either the population proportion is 80% or the population proportion is not 80%. That's it. There's no other ground to be filled. That's it. All possible outcomes looked at there. P is either equal to 80% or P is not equal to 80%. Okay? And every hypothesis test we're asked to carry out, that should be our opening step, is to make a note of what is the null hypothesis, what is the alternative hypothesis, and translate them into mathematics early. To test this hypothesis, we do a couple of things. We sample. Why do we sample? Well, we sample because it takes too much time and too much money to observe everyone in a population. We construct a confidence interval. Remember, from every single sample, a confidence interval may be constructed, and then we make a decision. Okay, we make a decision based on comparing what is the hypothesis to our confidence interval. And the decision is either going to be one or two of two things. You're either going to reject the null hypothesis, reject the claim, or do not reject the claim. Those are your decisions. There's no other decision. One thing we never do is we never accept. And I've seen some of our textbooks here do come up with the decision to accept the claim. They should not do that. You should never accept the claim. Okay, never accept the null hypothesis. In the same way that anyone who goes to the court of law is never found innocent. You're found either guilty or not guilty if you're accused of a crime. If you're found not guilty, that means there has not been enough evidence to prove your guilt. Okay, if you're found guilty, that means there has been enough evidence to prove your guilt. You're never found innocent. So if you're found not guilty, that doesn't necessarily mean you're innocent. That just means they haven't been able to prove your guilt. And so the decision is one of these two things. When do we reject? Well, we reject if and only if the claimed proportion, okay, the claimed proportion, in fact, let me write this in as P sub 0 maybe for the null hypothesis. If the null hypothesis claims that P is lower than the lower limit of our confidence interval, or if the null hypothesis claims that P is greater than the upper limit of our confidence interval. Okay, those are the conditions on which we reject. If they're not satisfied, then we do not reject. Okay, so I'm going to look at a couple of quick examples, just throwing in a few numbers here, and we're going to perform a hypothesis test. So here we have the null hypothesis is that P is equal to 30%. They're claiming the true population proportion is 30%. So what do? Maybe I don't quite believe them, so I go and I take a sample of 400 people, and from my sample I generate a sample proportion of 28%. So first two steps in every hypothesis test is to make a note of the null hypothesis. In this case, the null hypothesis is given, P is equal to 30%. That means the alternative hypothesis is P is not equal to 30%. Okay? What I'm going to do is I'm going to take a sample, which I've done, of 400 people, and I'm going to construct a confidence interval, a 95% confidence interval for the proportion. Now, to construct a 95% confidence interval for the proportion, we find our lower limit and our upper limit. But, you know, just remember, there's a kind of a formula, I suppose, for a 95% confidence interval for the proportion, and it's this. The lower limit is P hat subtract E, where E is the margin of error. The upper limit is P hat plus E. Okay? Where P hat is the sample proportion. So I've been given the sample size, I've been given the sample proportion. I haven't been given E, I have to calculate that. And on our course, the Leaving Cert ordinary level course, E is always taken to be about 1 over root. That's 1 over root 400 in this case, which works out as 0.05. But we're dealing with percentages here because everything's expressed in terms of percentages, so I'm going to convert that into a percentage. So my margin of error here is 5%. Following my formula for the confidence interval, I'm going from P hat 28% minus 5% all the way up to 28% plus 5%. So my confidence interval for the proportion is going to be from 23% up to 33%. Okay? So a quick reminder about confidence intervals is that from every single sample, and there will be an extraordinary huge number of samples of size of 400 that can be taken from a population, but from every single one of those samples a 95% confidence interval for the proportion can be drawn, and 95% of those intervals will contain the true population proportion, which means 5% of them will not. What do we think? Do we think our confidence interval does contain the proportion or does not? Well, given that 95% of them do, I would say I think that mine probably is one of the 95% that does. In fact, it's 19 times more likely that my confidence intervals does contain the true population proportion than it does not. So, what am I saying? I suppose, although it's not a great way to express it, but it kind of I gives a nice sentence to this, I suppose. I am 95% certain. Of course, you're either certain or you're not certain, but I'm saying, I'm 95% certain that P, the true population proportion, lies between 23% and 33%. So the question is, do we reject or do we not reject? Well, remember, we're going to reject if and only if the claimed value of P is less than 23 or bigger than 33. Somebody's claimed the true population proportion is 30%. I think it's between 23 and 33%, so they're not contradicting me. So my decision here, is to reject. Is not to reject. I can only reject if it lies outside of my confidence interval, is do not reject the null hypothesis. Why? Well, since 30% lies inside this limit or belongs to the interval from 23% up to 33%. Or another way to write that, rather than interval notation, I could write since 30% is bigger than 23% and less than 33%. It lies inside my confidence interval, so I cannot reject it. I don't accept the claim. Do I accept the claim? No, not necessarily, but I don't reject it. Okay, at the 95% confidence level. So there's not enough evidence to reject this claim about the population. Okay, so that's a hypothesis test. I either reject it or I don't reject it.